Look at example 8 on page 13. Evaluate each completely. Now, this is a bunch of different types of grouping symbols. Like in part A, we see square root of -5 minus 11. And the first thing we do is work within the grouping symbols, right? -5, treated as -5 and -11 is -16. So it's the square root of -16. But that negative is on the inside, isn't it? So that means that, what about that square root? It starts with a U. Nah, I'm just giving you. It's undefined. Undefined. And how about letter B? Letter B, negative square root of 9 plus 8. Now, we're not going to combine the 9 and the 8 together first. No. We actually do have a grouping symbol with that square root, so that we'll do that first. And there's nothing to do inside except to take the square root of 9. But it's okay to do so because that negative is on the outside. And negatives are on the outside of a square root, but not on the inside. So we get -3 plus 8. -3 plus 8 is a +5, or just 5. Ooh, here's one of my favorites. Letter C. Absolute value of 4 minus 6. Minus absolute value of -3. Here we have two separate grouping symbols. We have the first absolute value, and yes, absolute value bars are grouping symbols, just like parentheses. But they have more meaning than just parentheses might. And here's another one that we need to evaluate. But it's all in the same problem, that's the thing. Now, first of all, 4 minus 6. 4 minus 6 is -2, and that's the absolute value of it. Minus. Now, we could actually evaluate the absolute value of -3 right now and move on. In fact, let's do that. The absolute value of -3 is +3. +3. Oh, yes. I understand your question. For those of you who didn't hear it, the question was this. If I claim this to be +3, how come it's showing up as a -3? Like a -3? How come that's showing up? Well, the answer to that question is simple. It's the negative here that just came on down. Remember, when doing order of operations, we do it one step at a time. And so we'll see things like the +8 come down to the next level. When we're doing things at the same time, we can evaluate some, but maybe not the other. But that minus sign just stays with it. It's still -3. Excuse me. And then later on, if need be, we can write it as a -3, or however we need to. Let's continue with this. Absolute value of -2 now is +2. -3, notice it just tagged along. Now 2 minus 3, it'll be negative, that's right, and it'll be -1. Very good, -1. Now, I know what you might be thinking. You might be thinking, hey, wait a minute. Or maybe thinking, hey, wait a minute. Or something like that. But you're thinking, I thought absolute value made everything positive. Well, and it does. Because look, we got the absolute value of -2 and it became +2. And here the absolute value of -3 is the 3 and it's being subtracted. So the fact that we end up with a negative number is only due to the fact that, yes, absolute value did make certain things positive. But then once we no longer have the absolute value, we're not restricted to absolute value anymore. It's now just 2 minus 3. The absolute value part is gone. And we're looking at just 2 minus 3, which that part is -1. And that's A-OK. All right. I'm going to move on. Let's see if I can find the right page. Here we go. The main operation. The main operation. I made this up, by the way. I don't think you'll see it elsewhere, but I wanted to let you know about it. It's in the book, and we use it in different sections throughout the book. The main operation is the last one to be applied according to the order of operations. So sometimes we don't actually apply, addition, and we don't actually add or subtract, multiply, divide, we just look at the expression and not really do anything with it. But if we were to apply the order of operations to it, there's going to be one last step, one last operation to apply. And I say that that is the main operation. Yeah. So, I'm looking at example 9 on page 15. Example 9. It says, I'm going to read this out loud. Identify the main operation in each expression and state whether it is a sum, difference, product, quotient, power, or square root. Do not evaluate these expressions. Okay, I mean, we could evaluate them, but we're not asked to. We're asked instead to just take a look and identify the main operation. 6 plus 12 divided by 3. I remember doing this. That was like the very first problem. And I remember I did the division first and then the addition, because addition had the lowest rank, and it's the last thing to be done. That's the main operation. This is the main operation, addition. It's the last thing to be done, not the first. The last thing to be done according to the order of operations. So this, what's the main operation? In fact, it's written up here, isn't it, like that, in the book. Main operation. And then it is, okay, so the main operation here is addition. And that means that the expression is a sum. We call this a sum. I know that we see the division there. We don't call this a quotient, which would be the word for division. We don't call it a quotient because that's not the main operation. The main operation is addition. This is a sum between two things. Okay, that's kind of how main operation works. Here's letter B. 5 squared minus 8. Now, I don't know about your book, but I noticed that my book has a typo. My book says, at one point, 52 minus 8. And down here it says 5 squared minus 8. And it's intended to be 5 squared minus 8. So, just be aware of that. Now, what would we apply first? We would square first, that's right. And then we would subtract. Which one is last? Subtract, so we call that the main operation. Good. So the main operation is subtraction this time. I'll just abbreviate that for myself. That means that we have here a difference. One value minus another value. Let's see what letter C is. Oh, here it is. 24 divided by 6 times 2. This is the one where you will be so tempted to multiply first. But we don't. How come? I'll wait. It's okay. How come? Yeah, exactly. Division and multiplication have the same rank. And when they're both there, we have to apply them from left to right. So we would have to divide first, then multiply. Get that, from left to right. Because of the same rank, divide first, then multiply. Because multiply is done last, that's the main operation. I'll abbreviate that. Multiplication. So that means that this expression is a product. That's the word we use for multiplication. Talk about the expression. It's a product. Okay? Letter D says 9 minus 5 quantity squared. First thing we do is square. Oh, no. Grouping symbols. I almost wanted to square it first. Grouping symbols, here the parentheses, say we do what's inside first. So actually we would subtract first. Then we would square. So squaring is the last thing to be done. And so the main operation is the exponent. And the expression is a square, meaning a perfect square. Something being squared. Oh, I see I wrote it over there as a power. Power. All right, and last letter E. 6 plus 12 divided by 3. This looks a lot like the first example here. But what's different about it? Obviously, yeah, those parentheses, right? We didn't have the parentheses up here. Well, parentheses will change the rank of the operations, because it's got a plus sign in between, that means addition is the top rank because it's inside the parentheses, inside the grouping symbols. So we would actually add first and then divide. And in doing so, division becomes our last operation, so that becomes the main operation, division. And so that means the expression is a quotient. It's a quotient from division. Okay? Well, that's all I have. That's plenty, isn't it? But it's all I have for section 1.6. Hope you've gotten something out of this. Remember, read the book. Yeah, it's an important part. Just the videos alone aren't going to do it, because I want you to understand what's behind all of this. Okay. All right, you take it easy now. Maybe see you in the next video.